So today we are here with Arduino lecture. I guess this is actually number 2 or number 3. I'm not sure which. We'll have to figure that out. But today we are going to talk about using switches to control an LED. So we have a switch on the input and an LED on the output. I'm going to go ahead and share my screen and we'll look at this little program fragment. And we'll go from there. Let's see what we've got. All right, can everybody see?
Yep.
All right.
Yep.
Okay, so we have a simple situation here where we have an Arduino. And what we have is we have an input. And it looks like it is going to be pin 7. And pin 7, we are going to connect a push button switch. Okay, and from there, we are going to take this and hook this to voltage. So if we press down on this button, what we'll get is a pulse. Like so. Press down on the button, it provides a 5-volt pulse into pin 7. And then, connected to the output side, we have pin 13 up here, which will be connected to an LED. And this, of course, is our Arduino. Okay, so what we're going to do is we're going to look at the switch. Read the switch, and then we are going to decide, is the switch on? Yes. LED comes on. And if no, the LED comes off. Okay, so your LED will basically be equal to the status of the switch. Is that clear?
Yep.
So if I press the button and hold
Yep.
it down, the LED stays on. As soon as I let the button up, the LED turns off.
I understood because of, well, previous courses, so.
Well, I want to make sure that this makes sense to everybody. So, give me a thumbs up or tell me or whatever, so I know. James, what about you? You good? Does it make sense? I haven't heard you yet. They must be writing. Okay, so looking at our, let me go back to annotate here. All right, so a couple things that we're doing that may be new that we haven't seen before. If you notice up at the top here, we have INT, int LED pin equals You see that line up there? Int LED pin is equal to 13. So what we're doing here is we're giving pin 13 a friendly name. Which is LED pin. Okay, so now we can look at the program, and when we see over here, I'd like to move this out of the way. When we see over here, pin mode LED pin, instead of 13, because we've identified the word LED pin as being equal to 13. So we've given a friendly name. From now on, we can refer to pin 13 as the LED pin. Makes it easier to understand what the program is doing. The same is true for N pin. We're setting our input pin and giving it a name for pin 7. So now we can call pin 7 in pin and pin 13 LED pin. So when we get into the program here, which is the first thing that we're doing, pin mode, we're setting LED pin to an output and our in pin to an input. And you notice what the comments are here. We'll talk about those in a minute. Okay, so as we remember, this follows kind of the number 6. So this is our setup or the stem, which we only do once. We only need to define those as inputs and outputs once. We don't need to do it every time. And then down here is our loop. Okay, before we continue, notice the third line here. Val is an empty space. Used to hold the switch value. It's going to be either equal to a 0 or a 1 based on the setting of the switch. So if the switch is pressed and it executes that statement and reads it, val would be equal to a 1. We're started out with equal to a 0, and then it can change, and it will change every time we press the switch. Val will be what changes from a 0 to a 1, and that's what we will measure. Okay, so we've set up our pins as output and input, and then we get into the loop part of our program, which is here. And what we're going to do in the loop program is over and over again, we're going to read the value of our input pin, and we're going to store that value in our variable, which is called val. So if the switch is down when we execute that statement, val becomes a 1. If the switch is up when we execute that statement, val becomes a 0. And then we're going to take the value that's in val and send it to the LED. So we're going to read the value of the switch, store it in memory in a location called val, and then we're going to take the memory location and write it to the LED. So it's a 3-step process. 1, read the switch. 2, set val to switch value. 3, send Val to the LED. Okay, are we good so far?
Yeah.
Yep.
Yep.
All right, so the one thing I want to make sure that everybody understands is that I'm going to go ahead and erase unless anyone has any questions. Anybody need any more time or have any questions before I erase? Okay. Here's our 6. And as we said, it executes this once, and this is our loop. And it runs that loop literally thousands of times in a second. So this is going to be going around that loop over and over, which means that for all practical purposes, the LED follows the switch in real time. In other words, as soon as you change the switch, the LED changes. No perceptible delay. Okay, so even though it takes a certain amount of time for this program up here to execute and go through this loop over and over again, because it does it so many times in a second, you will not perceive a lag or a delay. Okay, we're talking about a couple of milliseconds, which your eyes can't perceive. Our eyes can only perceive something, a delay of about 200 milliseconds or so. Anything above that, we have a hard time perceiving that. Okay, any questions?
Um,
Go ahead.
sorry, didn't mean to interrupt.
No, it's okay. Got something, get it on. Let's do it.
So so this is different but the same from what we learned in a previous course about how the higher the voltage or the higher current going through the object, the faster it blinks. When, like we did with the LED test when we had electronics.
Yes, yeah.
That's because that was a square wave, I'm pretty sure. So
That was a little bit different. That's where we were doing, we were outputting a square wave by doing something like this, repeating this. Output, oh my, a 1, delay, output, a 0, delay, and then repeat.
Mhm.
Okay, so that's a little bit different than what we're doing here. Here, we're simply following a button, so there's no delay, no timing. Everything is happening in real time. So those two things are kind of completely different.
Gotcha.
Okay. Does that make sense?
Yeah. Basically, one's doing output on, then turning it off, out, on, off, on, off, on, off, on, off, on, off, really quickly, and then the other one is just don't stop, just keep going.
Right. Yep.
Yep.
So this program right here is really basically monitoring. What the hell was that? How'd that happen?
I don't know. You got the phantom marker apparently.
That
Then
was kind of cool.
it's
Man,
on.
it's
It's
starting to
off.
replicate the markers in the actual classroom.
Monitoring.
Even
I'm still not
online,
happy
we
with the
aren't
way this is laid out. Let's
able.
try that. Okay. So I want to talk a little bit before we finish up about comments. In other words, our program comments. What should program comments indicate?
Why the code is there.
Not what,
It's
but
like
why.
this turns on. So like this turns on the light, or this does this in the actual meat space, I guess you can say. Like this is what actually happens as a consequence of this.
All right, so look at these comments and tell me if these comments are good.
Uh, the setup comments are kind of bad. I know that because
These
it just
here?
tells you, well, yeah, it tells you exactly what you do. It tells you exactly what it says earlier of just it's putting the thing and turning it into an output. I can guess that by looking at the code.
Right. So it really doesn't tell you, and there, but there's not a whole lot you can do to this. But what I would do is certainly I would get rid of this and put LED
Hmm.
here, and then digital pin 7, I would put sets the switch, and I'd even go so far as to say push button. So I would certainly have that. Read the input pin, read the switch status, and LED sets the, yeah, I guess we could leave button, but I'd prefer to call it switch.
Yeah. And it's just important to be as precise as possible with this so that you know exactly what does what. And so you're not, hey, what's this do? Well, we have like 3 different switches. It just says switch here. So like, meh.
Yeah, well, it's kind of like when somebody asks you, what does a soldering iron do? It's an iron that solders. It gives you no information.
Yeah.
So the comments should give you additional or contextual information pertaining to what that statement is doing in the program, not what it does in the Arduino, but why is it there?
Hmm.
So, and that makes it easier later on when you have to try to figure out what the program did, or God forbid, you should have to take over somebody else's programming because they won the lottery and moved to Las Vegas or something. So, it is what it is. You're better off trying to comment your programs as well as you can, so that when you look at it 6 months later, you can have a clue as to what you did. Because remember, time is of the essence when it comes to these things. So we want to be able to have as much information at the get-go so that when we come back and look at it later and perhaps have to troubleshoot it or modify it, we can do that.
Yep. Yep.
All right.
So that, and so that you're not getting hexed later by your replacement.
Yeah, exactly. That's, or, these things have a way of coming around. You don't want to be the guy on the receiving end of that either.
Hmm.
Not in your
Yeah.
control, but once that happens once or twice, and you get a program and you're totally lost as to what it's doing, uh, and you're trying to figure it out from the comments, you'll learn that lesson real quick. Okay, so that is today's presentation
Alrighty.
on Arduino stuff. I'm going to go ahead and stop my share. Does anyone have any questions? I'm gonna then go ahead and stop the recording.
Mm,
Anybody have
no,
any questions that I can answer for anyone before we adjourn for the day?
not really. A lot of this was review for me, so like I'm just like,
Yep, and that's fine. That's all right. It's not review for everyone.
yeah.
So, you know,
I'm just like I don't have any questions because I'm just like, meh.
that's fine. It works out for me. So, you guys hopefully are getting your Arduinos hooked up and getting them to the point where you can write a program now,
Yep.
because that's where we kind of need to be. So we should be able to create that program that we just looked at. And again, I will have the video posted on our Canvas page, but we should be able to create that program with the Arduino hooked up and make it work. And if you need some help as to how to actually hook up the electronic components, just let me know. I think the book and the materials that you get on the disc with your kit is pretty explicit, but that does not mean it's going to be obvious.
Gotcha.
All right, so let's move on from here. If you have any issues getting your Arduino to work with your computer or any of that stuff, let me know and we'll have a special session, or you can bring your laptop in, bring it into class or whatever, and we can get that working for you. All right, and that's not
Gotcha.
just for the benefit of you guys, but remember, there's going to be people watching this that were not present at our lecture today. So I want to make sure that everybody knows we're here to get this done.
Uh-huh.
All right, any questions, any comments, anything anybody needs? Otherwise, I'm going to go ahead and stop the recording.